we're looking at the inside of an ear. And if you get curious enough, let me know. I can explain how an ear works. But there is one feature in particular I do want to talk about. So, as your sound waves enter into the ear, that information, that data, is transferred to the cochlea. So, it travels through the eardrum, through this inner ear bone, and makes it to the cochlea, this spirally snail-like shape kind of thing. Um, and inside the cochlea, they're tiny little hairs. So these tiny little hairs inside of this spiral is inside the cochlea, there's little hairs. Now, as you get older, these hairs start to die and they have difficulties picking up higher frequency sound waves. So these cells, these hairs, will still work for lower frequency quite well. But as someone gets older in age, you're going to find that the higher frequency waves, that higher pitch sound, is going to be much harder to perceive. So here's a funny story. In high school, this is like when cell phones just became a thing, and everyone needed to have a ringtone. Now, in class, once our physics teacher told us this thing about like what it means to really lose your hearing, when someone's losing their hearing, they're not going deaf, they just have difficulty hearing high frequency waves. So we would find a ringtone that would have a ridiculously high frequency, and we would set that to our ringtone. That way, when our phone rang in the middle of class, our old professor couldn't hear it, but everybody else in the class knew your phone was going off because that person couldn't perceive those higher frequency waves, while everybody younger in the classroom, all the students, could hear it perfectly fine. So, my phone would go off, everyone would look at me like, yo, dude, shut up your phone. But the teacher would never know